So, parallel in parallel out means what? So you have parallel in parallel out. Uh, so parallel in parallel out. Okay. So parallel in parallel out means so we will load the data. Parallel data is loaded simultaneously into the register. Okay. Data is
Okay.
transferred to the respective output by at the same clock. Okay. So that means loading and taking out the data. Taking out
Uh,
the data happens parallelly. Okay, parallelly. Okay, so that means so these both will happen at the same clock cycle.
same process.
Same clock cycle. Okay, so that means here if you see the pipo, so pipo will be like this. So this is the n bit pipo. N bit pipo means you have a clock. Okay, and this is LSB and this is MSB. Okay, some bits are there. Okay, so uh, mm, uh, this is parallel input. Parallel input we are loading parallel input, and you are taking out parallel output. So here this is LSB and this one is MSB, and here also this is LSB bit and this is MSB bit. Okay, so this is parallel out. Just we are loading the data parallelly and taking the data parallelly. So how to design? Suppose here how many flip flops? Suppose if you are using 4D flip flops.
For
Okay, 4D flip flops. So 4D flip flop. So here what happens? Here D and this is Q. Okay, and D Q D and Q D and Q. Okay. So let us take the parallel data you are loading is A. Okay. This is
A,
B and this
B,
is C and this one is D. Okay. Common clock as this is a synchronous sequential circuit. Common clock
common
is given to
clocks.
all the flip flops. Okay. All the flip flops common clock is given.
Okay.
And from Q you are taking out the data. Okay. Let us take this is Q1, Q2,
Okay.
Q3 and Q4. Okay. So you are taking out the data. How you are taking out the data? So parallelly you are taking out. Here this you are getting Q1 and here you are getting Q2
Q2,
and here you are getting Q3
3.
and Q4. Is it fine? It will take only one clock cycle to load the data and to take out the data. Just a parallel in, parallel out.
Okay, sir.
Understood?
Understood, sir.
Okay. Yeah. So remaining any doubts or queries related to CISO PIP serial shift register?
So the one what Mux. uh, So okay, sir.
Mux?
No,
You are
no,
saying something.
no, no. I'm okay, sir. No.
That is a D latch using mux and D flip flop using mux, D
Yeah.
flip flop using mux. You analyze that one, no? We analyzed, no?
Yeah. Yes, sir.
Okay, yeah. So next we will go with frequency divider circuit. So the frequency divider circuit is suppose if you see this is we need to generate means we need to generate the clock divided by two circuit. Okay, this is nothing but divided by two circuit.
Two
Okay,
circuits.
okay. So if you see you are using D flip flop. What flip flop you are using? D flip
D
flop.
flip
Okay.
flops.
So Q is given and the Q bar is connected as the input to D. Okay. That means complement of Q bar. That is Q bar is connected to the input of D. Okay. So here what happens? So first initially Q is 0. Q bar becomes what? Q is 0.
Zero.
Q bar becomes 1. No. So this
Okay.
q bar is connected as a D means what? So D equal to what? 1, no?
1.
1. Okay, this is the initial state. During, so this is the passage of clock. Means what? It will trigger during the passage of clock. Okay. So during the next clock edge, that means during this clock edge, what happens? Q becomes 1,
0, 1. Okay.
Q bar becomes 0.
0.
That will
Negates
come to D,
D0.
D0. Okay. So that means Q becomes 1 and Q bar becomes 0 and
0.
D becomes 0.
0.
Okay. And during the next clock edge, what happens? During this passage of clock, Q becomes 0,
0.
Q bar becomes
1.
1. Again, it will be feedback.
D will be 1.
Okay. So this will be 0 and this will be 1 and
1,
this
1.
will be 1. Okay. And during next clock edge, what happens?
Q become 1.
1, Q bar becomes
Q
0 and this will
0.
be feedback. Okay. So 1, 0,
0,
0.
0.
Okay. And next, during the next clock pulse, what happens? Q becomes 0, Q bar
Q bar
becomes 1
1.
and this becomes 1. Okay. So that is 0, 1, 1.
1, 1.
Okay. So what is the time period? This is the time period for my clock, no? You know the time period of clock.
Yeah.
This is my clock. Okay. From here to here, we call as one time period. Okay. From
Yes,
here
sir.
to here, we call as one time period. So what is the time period for this Q? You are getting T dash. What is this? T dash.
T
Okay.
dash.
So that means you can write T dash equal to what? Can you write 2T?
Can, sir.
Okay. You know that what is the relationship between frequency and time period?
1 over T.
Yeah, 1 over T. So here I am writing 1 by F dash equal to what? 2 by F. Okay.
F.
So from here, what is F dash? F by 2, no?
F by 2.
F by 2. Okay. So from here, it is satisfying that it is a clock divider by 2, no? 2 circuit. This is divided by 2 circuit. Why? Because frequency is the resultant frequency, that is wherever the Q value is there, you are getting the frequency is divided by
F
the clock
2.
frequency.
Okay.
Understood?
Understood, sir.
Okay. So how to calculate? Suppose if you take the master clock is 1 nanosecond, f equal to 1 by t means f equal to 1 by 10 power minus 9 means f equal to 10 power 9 means 1 gigahertz you will get. Okay. So clock frequency divided by 2 means t becomes 2
2
nanoseconds
nanosecond.
and f equal to 1 by t means 1 by 2 into 10 power minus 9 means you are getting resultant frequency is 0.5 gigahertz. My frequency is 1 gigahertz. When I am given to clock frequency divided by 2 means I get the resultant frequency is zero point
Giga.
0.5 gigahertz. From calculation also it is satisfying, no?
Yes, sir.
Okay, yeah. Next, we are going to design the clock frequency, that is clock frequency divider, that is f by n. Uh, so where n is odd integer number and clock frequency dividers for f by n when n is even integer. Okay. And where n is a decimal, suppose that decimal means you analyze. If you are not getting, I will tell you decimal. Okay. So I will tell you when n is odd and when n is
Yes.
even. Okay.
Even.
Now if you see, so for f by 3, for odd you take, for odd f by 3 if you take, we are using which counter means mod 3 counter.
Not 3.
Which counter? Mod 3 counter. Okay. So mod 3 means it will count from where to where?
0 to n minus 1. 2.
0 to 2, no?
Yeah.
If it is mod n counter, it will count from 0 to n minus 1.
N
So this
minus
is
1.
mod 3 count, n minus 1. This is mod 3 counter. It will count
So
from 0 to 2.
2.
Okay. So here what happens is, yeah, do you know the duty cycle? What is duty cycle?
Uh,
Duty cycle equal to T on by T on plus T of into 100. This is nothing but duty cycle.
Notice.
Duty cycle of any waveform you need to calculate. Okay. So when you are dividing, that means when you are using this frequency divided by 2, this will be off for how many clock cycles? 2 clock
2.
cycles. And this is will be on for how many clock cycles?
1 cycle.
1 cycle. So if you calculate 1 by 1 plus 2 into 100, how much you are getting?
3, 3.
33.33, no? 1 by 3 into 100. Calculate.
Yes.
Okay. You will
33
get
point.
33.33%. Okay. So actually you need 50% duty cycle.
50% duty cycle.
50% duty cycle. Okay. So that means here, if you see, if you observe here, it is off for 2 clock cycles and on for 1 clock cycle.
One clock cycle.
Okay, 2 clock cycles it is off and 1 clock cycle it is on. Okay. So in order to get 50% duty cycle, so total clock cycle is 3, no? So 3 by 2. So it should be off for how many clock cycles?
1.5.
1.5. It should be on for 1.5. So you need to alter this from zero point 0.5 clock cycles from here. Just
1.5 to 1.5.
1.5. Next it will take 1.5, 1.5. To
Yeah.
alter that, what you are doing means you are using negative edge trigger D flip flop.
Negative
Edge
H.
trigger D flip flop.
Okay.
Okay, negative edge trigger D flip flop. Okay. So see here. This is nothing but Q1. Q1 with this is not 50% duty cycle. What duty cycle you got?
33.33.
33.33%. Okay. So this is a neg edge of clock. This is neg edge of clock. So here what happens during this neg edge of clock? This Q1 is acting as an input to this D flip flop. No?
Yes.
So that means whatever the Q1 is there, you are getting here,
0.
and it will be 0 till next neg edge. So this is 0 only, and this will be 0 till next neg edge.
0, 1.
Okay. Again here it will check. Here this is 1 means this becomes 1.
1.
Okay, and this will be 1 till next neg edge. Okay, again here it will check. So this is 0 means 0. Again here, uh, uh, so it will be 0 till next neg edge, and next during this it becomes 1. Okay.
1.
Now what happens? You need to make you need to add these two signals by using which gate means OR gate. Okay, you need to add, that means you need to use this OR gate for output of Q1 and Q2. Okay, so when you add, so here what happens, 0 or 0 means you are getting 0, 0 or 0 means 0. Again here uh, here 1 is there. Okay, 1 or 0 means here 0 or 0 means you are getting 0 only, but
0.
here 1 you will get. Here 1 you will get, here 0 will get, here 0 will get, here you will get 1, 1, like that. So you are converting this 33.33% duty cycle into
50.
50%. So if you observe, this is 1 clock cycle and this is zero point 0.5 clock cycle. So total it is on for 1.5 clock cycle and this is off for 1.5 clock cycle.
1.5 cycle.
So you got duty cycle is how much? 50%, no?
Yes, sir.
Yeah. Yes. Next, if it is a modify counter, 50% duty cycle, this is off for how many clock cycles?
4.
This is on for 1 clock
1.
cycle. So 5 by 2,
Uh, 5 divided by 2, right, sir?
2.5, no? 5 by 2
Yes.
means what? It should be on for 2.5 clock
2
cycle
point, 2.5, sir.
and it should be off for 2.5 clock cycle. So that means what happens means you need to alter zero point 0.5 clock cycle and after that you need to alter the output by 1 clock cycle. Okay. So when you want to alter zero point 0.5 clock cycle, which flip flop you are using?
Uh,
negative edge trigger D
D
flip
flip
flop.
flop.
If you want to alter the frequency by one clock cycle, you need to use positive edge trigger D flip flop. Okay. So see here, we are using this is to alter one frequency, positive edge trigger D flip flop, and to alter the output frequency by one clock cycle. And this is negative edge trigger to alter the output frequency by zero point 0.5 clock cycle. So these all outputs are given to which gate? OR gate.
OR gate.
Okay. So here what happens? You are using two flip flops, no? Means in order to optimize this, is there any option? Is there?
Uh, it's D.
Just to check the states.
Uh, 0 0. Oh, that one 0 0 will be 1. It's
Mhm.
like toggling, right, sir? 0.
So in order to see Q2, can you see Q1? See here. This is off. This is off
Okay.
for how many clock cycles? Three
Of
clock cycles. And this is on for
2.
two. So I need to alter the frequency by how much?
0.5 and
0.5. Yeah. So here we need to optimize. For this, you need to use Q1, and you are using only one negative edge trigger D flip flop. Is it fine? Did you understood?
uh, understood, sir.
Okay. Yeah. So conclusion. So first we need to include a modern counter, and if it is a positive edge trigger flip flop, we need to alter the output by how much clock cycle? One clock
1
cycle.
clock cycle.
And the negative edge trigger flip flop, we need to alter the output by half clock cycle.
Half
Okay.
clock
So
cycle.
need to choose an output of modern counter having the frequency f by n. Okay. Less alternation required for hardware optimization.
Optimization.
Okay. Understood?
Understood, sir.
Okay. And next, f by 7 means what?
Uh,
This is off
uh,
for how many clock cycles?
6. Okay.
4, no? 0, 1, 2, 3, 4. This is off for 4 clock cycles.
So clock
This is
cycle.
on for
3
3 clock
clock
cycles.
cycle.
So 7 by 2. How much?
3.5.
So it should be on for 3.5 clock cycles and it should be off for 3.5 clock cycles in order to get 50% duty cycle. So you need to alter the frequency by how much from here?
0.5.
0.5. For this you need to use negative edge
Negative
trigger blue flip flop.
D flip flop.
Okay, understood.
Understood, sir.
Next, if it is a frequency divided by 2, we are using which counter? Mod 2 counter, no?
Motto counter.
Mod
So
2 counter. This is off for one clock cycle. This is on for one more clock cycle.
one
One
more
clock
clock.
cycle. So directly we are getting 50% duty cycle, no? Is there any extra hardware is required?
No need, sir.
No need. Directly you can design the Mod 2 counter. You will get the Q naught with 50% duty cycle. And F by 4,
No need also, sir. 2
no
2.
need. So 2 2. Okay. So no need of extra circuit. And F by 6,
3 3, sir. No need. Eh,
4
oh, 4
2.
1. 4 2.
4 2. 6 by 2,
Yeah. 3
3. So you need to alter the output frequency by how much?
1.
1. So you need to
So
use which flip flop?
positive
S
D
trigger
flip
D
flop.
flip flop. So this waveform you can analyze, no?
Yeah.
So normally what you are getting means so on means you are getting on by, so 2 by 2 plus 4 into 100. So this is 1 by 2 by 6, 1 by 3 into 100%. So here also you are getting 33.33%. Okay. So you are using positive edge trigger D flip flop. Okay. Q2
Okay.
is not 50%. This is 33.33%. And you are using positive edge trigger D flip flop. You need to make R operation so that this will be on for 3 clock cycles, and this will be off for 3 clock cycles.
3 clock cycle.
Okay, so 3 clock cycle, 3 clock cycle. Duty cycle is 50% you are getting. Did you understand?
Understood, sir.
So this is about the frequency divider circuit.